Yeah, hello children, welcome back to Chemistry Wala classes. This is Satish Kumar. In this video, I am going to talk about VBT, Valency Bond Theory. So what is the importance of valency bond theory? I am going to give you. That is, VBT explains formation of covalent bonds with the help of orbitals overlapping. So VBT, valency bond theory, mainly tells covalent bond formation with the help of orbitals overlapping. So it was given by Hitler and London in the year of 1926. Later it was developed by Pauling and Slater in the year of 1931. So VBT explains covalent bond formation with the help of orbitals overlapping. So here orbitals overlapping is two types. Orbitals overlapping is two types. First one is end-end overlapping. End-end overlapping of orbitals. Second one is partial overlapping of orbitals. Then I am going to give you the end-end overlapping of, very important, that is end-end overlapping of orbitals will form strongest bond in between the atoms, will form strong bond in between the atoms, is called sigma bond. So sigma bond is formed by end-end overlapping of orbitals, and sigma bond is the strongest bond in between the atoms. And partial overlapping of orbitals will form pi bond in between the atoms. It is the weakest bond. So partial overlapping of orbitals will form pi bond. So overlapping of orbitals have given two types of bonds. One is sigma, another one is pi. Sigma notation is this and pi notation is this. So what are the best molecules to show sigma bond and pi bond is our next point. So here I am taking to explain the sigma bond formation. I am taking H2 molecule, HF molecule and F2 molecule, because SS overlapping will form sigma, SP overlapping will form sigma, PP overlapping will form sigma. I mean s orbital end-end overlapping, s and p orbitals end-end overlapping, p and p orbitals end-end overlapping will form sigma bonds. So in the H2 you will find SS overlapping, in the HF you will find SP overlapping, in the F2 you will find PP overlapping. So we will start here. First of all, H2. So H2 molecule. So two hydrogen atoms are there. Hydrogen electron configuration 1s1. So s orbital is there in the hydrogen. So this is the first hydrogen s orbital along with electron. So clockwise electron and s orbital spherical shape. Then second hydrogen also you have to draw, because H2 molecule formed by two hydrogen atoms. So this is the second hydrogen anti-clockwise electron. So to form the VBT, the important point in the valency bond theory, to form a bond, either sigma bond or pi bond, the orbital should contain unpaired electrons along with opposite spin. One is clockwise, another one is anti-clockwise. So here two hydrogen atoms SS orbitals are end-end overlapping. So here the electron pair, and this is the bond between the two hydrogen atoms. So you can write H2 molecule. So H2 molecule formed by both hydrogen atoms s orbitals end-end overlapping. So in between the orbitals overlapping, you can find one is clockwise electron, another one is anti-clockwise electron. So this is called a sigma SS overlapping. H2 formation is the best example for sigma SS overlapping. Then you can take here HF, hydrogen fluoride molecule or hydrofluoric acid, best example for the sigma bond formation where s orbital and p orbital overlap. So hydrogen 1s1, and you can write like this: fluorine 1s2, 2s2, 2p5. The electrons in the orbitals you can write like this: 2p5. So it is px, it is py, it is pz. One unpaired electron is there in the pz. So hydrogen s orbital clockwise electron, and fluorine pz. So pz of fluorine. So here anti-clockwise electron. So to overlap, the orbital should contain unpaired electrons with opposite spin. So here hydrogen s orbital, fluorine pz orbital, end-end overlapping. This is what. So here HF, single bond in between the hydrogen and fluorine, which is equal to sigma sp overlapping. And next third one is F2 molecule, where with the help of pp orbitals overlapping, sigma bond can form. So F2 molecule is the best example where the p orbitals end-end overlap and sigma bond can form. So again you need to write fluorine 1s2, 2s2, 2p5. Same unpaired electron you will get in the pz. So px filled with 2 electrons, py filled with 2 electrons, but in the pz unpaired. So F2, two fluorine atoms, pz orbitals I am taking. This is pz of one fluorine. This is pz of another fluorine. So here end-end overlapping. This is the end-end overlapping in between the p orbitals of two fluorines. Then this is called sigma pp overlapping. So finally you got sigma bond is formed by pp orbitals overlapping and sp orbitals overlapping and ss orbitals overlapping. And you need to remember here sigma bond is strongest bond. in between the atoms, and the first bond between the atoms in a molecule, the first bond in between the atoms in a molecule is sigma bond, and the sigma bond is permanent bond because it is the first bond forming in between the atoms. So strongest bond, first bond, and permanent bond. Next, pi bond formation we'll see very simply. So what is pi bond? I told you pi bond is formed by partial overlapping, of orbitals. How two orbitals partially overlap and form pi bond? We are going to check with the help of two examples. One is O2 molecule, second one is N2 molecule. So we will find first O2 molecule. So how O2 molecule will form? So you have to write oxygen atomic number 8, 1s2, 2s2, 2p4. So this is the electron configuration of oxygen. So actually two unpaired electrons are there, px, py, pz. So unpaired electrons are present in the py and pz. So you know very well p orbitals are dumbbell shape. So it is the py, it is the pz, for example, having unpaired electrons. So py, pz of oxygen. Then another oxygen also same you have to draw, py and pz, but opposite spin, unpaired electrons anti-clockwise. So py, pz of oxygen. So here also, first of all, I am taking first oxygen py with the second oxygen py end overlap. How? This is the model. So sigma bond end overlapping, that is py, orbitals of two oxygens. Then first oxygen pz, second oxygen pz partially overlap. Then you will get pi bond, which is called pz. And here the O2 molecule structure you can show like this. Both oxygen has given 2 electrons, because oxygen valency electrons are 6. In that 6, 2 are participating in the bonding. So this is sigma, this is pi. Sigma bond formed by py, pi bond is formed by pz. So here the overlapping you can take from downside also, because pi bond is formed by above the plane, below the plane, nothing but above the internuclear axis, below the internuclear axis. So this is what O2 formation, pi bond. And next, N2 formation. So nitrogen atomic number 7, you can write 1s2, 2s2, 2p3, not 5, because 7 electrons, 1, 2, 3, px, py, pz. So 3 unpaired electrons are there in the valency shell orbitals. So first of all, px, py, pz, you can draw like this, px, py, pz of first nitrogen, because n plus n you will get n2, and in the previous example also O plus O you will get O2. So just reminding. And unpaired electrons in px, py, pz of first nitrogen. Then another nitrogen also same, but you need to remember the electron should be anti-clockwise. So px, py, pz of nitrogens. Then you can check here, first px end overlap will give you sigma bond in between the two nitrogen atoms. So here you have to draw carefully. This is the method to draw slowly the orbitals, because the diagram is important. So here you have to draw. Then for example, py pz. I told you pi bond is formed by partial overlapping of orbitals. You have to show along the knot, above the internuclear axis, below the internuclear axis, the overlapping. So here 2 times. So it looks like 3 bonds. This is sigma, this is pi, this is pi. So px give you sigma, py give you pi, pz give you pi. So 1 sigma bond, 2 pi bonds in the N2 molecule, and this is the orbitals overlapping in N2. And finally I want to tell 3 points about pi bond. That is, pi bond is temporary bond, and pi bond is weakest bond, because after forming the sigma bond, pi bond will form. So we are calling temporary bond. And orbitals partially overlapping and giving us pi bond. So that is why partial overlapping always weak, so we can call weakest bond. And third point is, just now I have given here sigma bond. What are those? Strongest bond, first bond, permanent bond, and always it exists as second bond. What is the meaning of it? After forming the sigma bond, the pi bond will form. That is why we are calling second bond. So these are the main postulates of sigma pi bond formation with the help of VBT. I hope you got it. Thank you.